Welcome to the Deep Dive. Today, we're tackling one of the real gems of mathematics, Euler's identity. You know, the one EIP plus $1.
Absolutely beautiful. Connects so many fundamental constants.
It really does. But we came across some source material, really interesting stuff, that presents it with a slight, well, a twist. And our mission today is really to unpack this enhanced form, as the source calls it. It does a great job, actually, highlighting the role of the exponential function itself.
Yeah, and what's quite neat about it, this reframing, is that it arguably works as a more, let's say, accessible entry point for understanding the wider Euler formula, EI theta plus I sin theta.
How so?
Well, it makes the connection clearer not just for pi, but quite explicitly for when theta is 0 as well. It lines them up side by side in a way.
Okay, I see. So the actual expression they use is EIP plus E dollars. Now, I admit, when I first saw that, I thought, why complicate it? You know, that plus one feels so clean.
Right, it's iconic as plus one.
But reading through their explanation, you start to see the elegance in this version, too. Let's quickly walk through it like the source does.
Sure.
So first, you've got the AP term. If we bring back Euler's formula, AAP theta plus I sin theta, and we plug in dollars for theta, we get EPP plus I sin paid. Okay, so cosine of theta, that's minus 1.
Right.
And sine pi of theta is just 0. So the imaginary part vanishes,
Got it.
meaning APAT. It boils down to minus 1. Simple enough.
Exactly. -1.
Then we have the other term, EPTO, and this is where the original plus 1 is kind of hiding, right? Or where it comes from.
Precisely. It's giving it its origin, so to speak.
Because any non-zero number raised to the power of 0 is, by definition, 1.
Always 1.
So ET is just 1.
Yep.
So now you put them together. You've got 1 from the E epitar and plus 1 from the E part. And, well, $1 plus OA1 obviously equals 0.
It holds perfectly.
It does. The identity's still true, just presented differently. But, like you hinted, this isn't just shuffling symbols around for fun, is it? What's the deeper meaning here? Why show T dollars explicitly?
No, definitely not just a trick. It's about showing something fundamental. This form, EP plus ETI, really puts the spotlight on the unity of the exponential function.
Unity? How do you mean?
Well, think about it. It shows the same function, x dollars raised to some power, operating in two seemingly different worlds. You have AP, which involves complex numbers, rotation in the complex plane.
Right, the imaginary component.
And then you have T dollars, which is purely in the realm of real numbers, just one on the number line. This way of writing it emphasizes that the same core function, the exponential, is responsible for both the results.
Ah, okay. So it's not just about E, Ty, and Tim making mech of S1, but about the exponential function itself behaving consistently, whether the exponent is complex like AP or simple like 0?
Exactly. It connects the complex exponential with the real exponential directly within the identity itself. It reinforces that idea we mentioned earlier. It makes the theta pi case and the Euler pi case of Euler's formula sit right next to each other.
That makes a lot of sense. It's like seeing the underlying machinery is the same, even if the outputs look quite different initially. One involves imaginary numbers, the other doesn't.
Precisely. It's a statement about the coherence of mathematics, showing these domains are linked by this fundamental function.
That's actually really compelling. Such a small change, writing 1 as $2, but it reframes it to show this deeper connection. It really highlights the consistency, the elegance of it all.
It does.
So to wrap up this deep dive then, we looked at Euler's identity through this slightly modified lens, EPP plus E of dollars, and doing that, as our source material argued, really emphasizes how the exponential function acts as a unifying concept across both the complex and real numbers.
A bridge between those worlds, yeah.
It's a fantastic reminder of how interconnected math really is.
And maybe a final thought for you to take away from this. As you look at other things, whether it's math, science, or just problems you're trying to solve, consider this idea.
Yeah.
Sometimes the biggest breakthroughs, the deepest understanding, doesn't come from finding something brand new. It comes from looking at what you already know, but from a slightly different angle.
Like seeing the 1 as T dollars.
Exactly. That little shift in perspective can suddenly reveal connections, these unifications that were hidden in plain sight. So maybe keep an eye out for those opportunities to just tilt your head and see familiar things in a new light. You might be surprised what clicks into place. We're going to unpack how a fundamental mathematical identity, you probably know it, Euler's identity, is being, well, dramatically expanded. It's really ambitious. They're trying to weave in ideas from physics, neuroscience, maybe even how large language models actually process information.
Euler's identity. Yeah, elegant, simple, but this sounds like a serious twist. Okay, so your material mentions this enhanced Euler's identity with scaled perturbation. Let's try to get our heads around that. It takes the classic formula and adds all these intricate new pieces.
Yes, that's the core of it. And what's fascinating, I think, is how it pulls in such a wide range of wave functions. Think of less like one equation and more like a master term, maybe a collective pulse. It captures the combined influence of many, many different kinds of waves, sort of a root of squares approach.
Okay, different waves. And this is where it gets really interesting for you, the listener, because we're not just talking standard physics waves here, are we? Your sources list the classic wave function. Okay, fine. But then a causal wave function, entropy wave function, even an fMRI wave function.
Right, tying it directly to brain activity measurements.
Exactly. And then it gets even more audacious. A consciousness wave function and something called an Orch or wave function. Hold on. A consciousness wave function. That seems incredibly abstract. How do you even quantify consciousness mathematically like that?
Well, that's precisely the frontier they're pushing, isn't it?
Yeah.
The Orch-RR one, for example, that directly links to the Penrose-Hameroff theory. The one about quantum processes in the brain being potentially key to consciousness itself.
Okay, so they're trying to give it a mathematical slot in the equation.
Exactly. They're treating consciousness, or at least these theoretical models of it, as a measurable influence, a quantifiable pattern within this bigger framework, basically trying to capture things like brain states and maybe consciousness numerically.
Right. And just when you think, okay, maybe I'm grasping the scope, the sources throw in the Andromeda paradox normalization.
Oh.
Andromeda? What on earth does another galaxy have to do with brainwaves and consciousness equations?
Yeah, that's a good question. Why bring in something on that scale, the distance to Andromeda? It really suggests they're attempting to account for influences across, well, truly vast scales. Maybe huge data sets, maybe even cosmological effects are somehow part of the picture. The scaling idea.
Oh, sure.
Perhaps it's inspired by how LLMs handle just immense amounts of diverse information to find, emergent intelligence.
So it's like the scaling itself is the key idea.
Possibly. They might be trying to model emergent properties in really complex systems, asking if consciousness, or even the universe, has properties that only show up at these massive scales.
So, okay, they're stretching Euler's identity, but it's not just adding terms. It's almost like trying to mimic the scaling up we see with LLMs. The real surprise isn't just what they're mixing together, quantum stuff, brain stuff, consciousness theories, but the idea that consciousness and the cosmos could fit into one mathematical structure.
Yeah.
It's kind of like asking, if you feed an AI enough diverse text, you get emergent intelligence. So can you apply similar scaling principles to physics and biology data streams and find emergent properties of, well, reality itself or consciousness?
Precisely. This deep dive, it really highlights an incredibly ambitious effort, trying to model these really elusive phenomena, consciousness included, through a unified, integrated mathematical lens, and drawing inspiration potentially from how these huge language models manage complexity.
So as you think about this, what new insights could possibly open up if fundamental maths can genuinely wrap its arms around something as slippery as consciousness, something potentially influenced by the scale of the entire universe? Makes you wonder, doesn't it? What other big mysteries might be connected through these kinds of scaling ideas?
Fascinating. A model exploring how your thoughts, well, how they don't just sit in your head,
Right.
but how they dynamically evolve and actually seem to influence the reality you experience. It's quite a concept.
It really is. And our mission in this deep dive is essentially to unpack this complex framework. We'll focus on the key bits. This idea of a composite wave for your thoughts.
Okay.
And something really intriguing, a fractal memory archive. They call it the Menger sponge.
Menger sponge, right?
Yeah. The goal is for you to get a handle on how these elements kind of working together suggest thoughts, impact your perception, your choices, even how you interact with your environment profoundly.
Okay, let's unpack that first piece then, the composite wave.
Yeah.
So the model suggests that all these different cognitive processes, they aren't separate tracks.
Exactly.
They combine into one unified thing, like an orchestra playing one big piece.
That's a great analogy, a symphony of cognition. And what's really interesting here is what makes up this symphony. Some parts you might expect, others are, well, pretty surprising.
Like what?
Well, you've got the basics things reflecting your brain's electrical rhythms, alpha waves, theta waves, that kind of thing. The classic wave function stuff.
Standard brain activity.
Okay. But then it adds layers, components trying to capture subjective consciousness itself, your actual awareness. Think integrated information theory, that sort of angle.
Ah, okay. So consciousness itself is part of this wave.
It's in the mix, and it gets even wilder. The model brings in geometric relationships like Penrose's twister theory, hinting maybe thought isn't purely local in the brain.
Whoa, okay. Non-local.
And even speculation linking thought to quantum processes, the whole OR idea. Quantum consciousness may be playing a role.
So it's this incredibly rich blend that's saying your thoughts aren't just one simple thing, but this dynamic mix of brainwaves, consciousness, geometry, maybe even quantum stuff.
Precisely. An integration of all these diverse processes. It's a lot to take in for just thinking.
It definitely is. So that covers the active thought part.
Yeah.
But what about memory? Our past experiences, how do they fit into this dynamic picture?
Yes. Memory. That brings us to the second key piece. This really unique concept, the Menger sponge. It's proposed as a kind of fractal temporal memory archive.
A fractal memory archive. Okay, break that down. What is a Menger sponge, first off?
So imagine a 3D cube, and you start removing smaller cubes from the center of each face and the center of the whole thing, and then you repeat that process on all the smaller cubes that are left infinitely.
Okay, I'm picturing this sort of infinitely holy cube.
Exactly. It's got this fascinating self-similar structure, infinite surface area, but zero volume, technically. Its fractal dimension is about 2.727, not quite 3D.
Wow. And this structure stores memories.
Not just memories, but what the model calls Gödelian fixed points, sort of key stable states or insights from your cognitive processes over time, stored within this fractal hierarchy.
So how does that work for you, for your thinking right now?
Well, the idea is it's hierarchical. Your most recent thoughts, maybe recent fixed points, they might be stored in the larger, more accessible levels of the sponge.
The outer layers, maybe?
Sort of. And then deeper down, in the finer structures, you might have sparser, older data, foundational patterns, maybe even patterns from, deep history or culture encoded somehow.
So,
yeah,
like 1000 BC, as the outline hinted. That seems ambitious.
It's speculative, for sure. But the principle is that this structure allows your current thinking to access deeply contextualized historical patterns almost instantly, influencing your perception, your decisions now. Your past is always present, contextually.
Okay, that's a mind-bending way to think about memory. Which leads us to the big question then. How does all this, the composite wave, the fractal memory, actually shape reality?
Right. How does thought influence the world?
Yeah, it sounds almost mystical, but what's the mechanism proposed here?
Well, the model connects it in a few ways. First, perception. That composite wave, integrating consciousness and metacognition, it's actively organizing your sensory input.
So I'm not just passively receiving sights and sounds.
Exactly. The idea is your thought actively constructs your subjective reality. It aligns with constructivist ideas you're building your perceived world.
Okay. And decisions. How does thinking affect what I choose to do?
That's where the Menger sponge really comes in. Those past cognitive states, the archived fixed points, they directly influence your present choices and actions.
So my history, stored in this fractal way, biases my current decisions.
In a way, yes. It allows historical patterns to impact your present choices. And those choices, of course, change the physical or social reality around you.
Makes sense.
And then there's that quantum hint again. The quantum-like aspects of the wave functions, combined with maybe storing quantum-like states in the sponge, it suggests a kind of probabilistic influence, meaning your thoughts might subtly nudge which potential outcomes become actual. Not direct control, maybe, but like tilting the probabilities, metaphorically shaping reality by selecting pathways.
Wow. Okay, so wrapping this up, the big takeaway seems to be that our thoughts are way more dynamic, interconnected, and frankly powerful than we usually assume.
Absolutely. They're not just echoes in the skull. They seem to be actively building your perception, influencing your choices, and subtly shaping your reality through these intricate wave interactions and this deep fractal memory.
It's a profound perspective.
It really is, and it leaves you with a pretty provocative question to mull over, doesn't it?